So let's turn to Chapter 3 in Alkane Chemistry and look at the rules for nomenclature, the naming of alkanes. So if we take a look at the top 10 for the alkanes, of course the simplest alkane is methane, CH4, and that chemical formula follows a basic structure for alkanes of CnH2n plus 2, which means basically for every carbon in the molecule there's twice as many hydrogens plus 2. So one carbon, twice as many, which would be 2 for the number of hydrogens, plus 2, which gives a 1, 2, 3, 4. And we find that all of the basic alkanes follow this formula. So from methane we go to 2 carbons in ethane, C2H6. For every carbon, double the number of hydrogens plus 2. Likewise with propane with 3 carbons, C3H8. And the same idea with butane, pentane, hexane, heptane, octane, nonane, decane. So whatever the carbon count is, double that count and add 2 and you'll get to the relevant number of hydrogens. And we say that the alkanes are saturated. They have the full complement of hydrogen to fill the octets of each carbon. And so that CnH2n plus 2 rule cannot be exceeded. There's no more room for hydrogens on this number of carbons. Now, naming the alkanes, if we look at this example here and think about the basic structure of the name, we'll have a suffix at the end of the name, which is basically the functional group present in the molecule. And in this example, it's the OH or alcohol group in red. So we'll see lots of different kinds of functional groups. For example, if the molecule has a carbon-to-carbon double bond, that's what we call an alkene. If it has a carbon-to-oxygen double bond on the end of the molecule, that's what we call an aldehyde. If it's embedded in the molecule, the carbon-to-oxygen double bond, we call it a ketone. And of course the alcohol group, as we've seen, amines when there's an NH group, and carboxylic acids when it's a COOH group. There are others, but these are some of the more common ones which we'll see during the semester. So the name ending is based on the kind of functionality we have, although for the molecules that we are going to look at in this chapter, the alkanes, it means that our suffix is ANE. All of the alkane names finish in ANE. We also will look at the parent chain of the molecule. That's the longest continuous chain of carbons, and however long that is, the parent name will be based on one of the first 10 alkanes. So for our molecule here, as we look at the longest continuous chain, we've got 1, 2, 3, 4, 5, 6, 7, 8 carbons in a row. So this molecule's name would be based on the octane molecule, which is the alkane with 8 carbons. In front of that parent name, we put in the prefix, which is the branches in the molecule, and we have some branches here. The fluorine atom, which is branched off the main chain. The where is it? There it is. The methyl group, which is branched off the next carbon, and then the propyl group, 1, 2, 3 carbons long, based on the next carbon again. And then we've got to locate these prefixes. The locant, which is numbering the main chain to tell us which carbon in the chain these branches are associated with. So let's look at some examples and build our molecule up based on these rules. So rule number 1 is just find the longest continuous chain of carbons. Now as we look at our example here, we could start here and head to the right to give us 1, 2, 3, 4, 5, 6 carbons. But if we started here and continued to the right, we'd also get 1, 2, 3, 4, 5, 6 carbons. So we have a tie in this situation. And so our sub-rule for the first part here is that we're looking for the longest continuous chain of carbons which has the most branching from that point. So if we look at those two routes that we looked at, if we go from here to here, we see 1, 2, 3 branches off the main chain. But if we started from here and finished up here, we'd only see 1, 2 branching points. So the first option is the best option, and it gives us a most continuous chain of carbons with the most branching. We look at our second rule. That's that the number of atoms in the parent chain need to be counted, and they need to be numbered. They need to be numbered to give the lowest possible position to the first branch in the molecule. So we're either going to start here or start here, because we decided that this was the longest chain with the most branches. If we start on the left, then we see the first branch, the chlorine, at carbon number 2. But we get the same answer if we start on the right and count backwards. The first branch, the fluorine, from this side, would also be on carbon number 2. So we need something to break this tiebreaker, and that sub-rule for part 2 is, when there's a tie, find the lowest possible numbering for the next branch. So following that rule, the branch, the first one is on carbon 2, but the second branch would be on carbon 3, as we count from the left, this ethyl branch. But if we're counting from the right, we don't see the second branch until we get to carbon number 4. So we'll count the number of carbons from the left to right in this case, because we get a lower possible numbering. So we go 1, 2, 3, 4, 5, 6. Our branches on carbon 2, 3 and 5, instead of the branches being on carbons 2, 4 and 5. Next thing we want to do is to identify and name the substituents, the branches on the molecule. We know where they are. They're on carbons 2, 4 and 5. And to give them their name, we've got a chlorine on carbon number 2, and we take off the INE ending for the element and change it to chloro. So chlorine becomes chloro. And then for the alkane branch on carbon number 3, we take the parent name of the alkane with, in this case, 1, 2 carbons, which would be, where are we? Oh, no, there we go, which would be ethane. And so that name is changed from ANE to YL. So ethane is expressed as ethyl when it's just a branch on the molecule. The last branch, which is the fluorine, just as we did with the chlorine, that fluorine is changed to fluoro as a branch in the molecule. So these name changes to the ends of the element or the alkane substituent tell us which elements and atoms are main chain, the parent chain, and which are considered branches on the molecule. So we've got the names of the branches, and we've figured out the position for those branches because we've numbered the main chain. The last thing is just to put all those pieces together. We'll use dashes to separate numbers and letters, and we'll use commas to separate numbers. So for the name of this molecule, we get 2-chloro, 3-ethyl. That's our prefixes to the molecule, along with the 5-fluoro, of course, 3 of them all together. And then the name ending, the suffix is ANE because it's an alkane, and the parent chain is 6 carbons long, so it's hexane. Now you can't tell from this example here, because our branches are listed in numerical order, which also follows alphabetical order: C for chloro, E for ethyl, and F for fluoro. But keep in mind, as we look at other examples in another video, when it comes to the listing of the branches, the prefixes, we'll list them in alphabetical order rather than numerical order. But that numerical order has already been set in. So let's stop the video there, and we'll look at some more examples in another video later.